Our next speaker, he is an industry leader in developing practical applications and standards for AI, including recent research in explainable AI, ethical AI, and responsible AI. He also serves on the board of directors of Tech San Diego and Cyber Center of Excellence. We're so delighted to have with us Dr. Scott Zoldi, Chief Analytic Officer, FICO USA, to tell us more about the resilience of responsible AI. Dr. Scott, please.
Hi, everyone. This is Scott Zoldi. It's a great pleasure to be speaking today on the topic of the resilience of responsible AI. We are in a time in our evolution of the use of AI and machine learning where focusing on what it means to be responsible in the use of machine learning technologies that impact people has never been more important. And so it's a great pleasure to talk about what it means to build models that are responsible and to talk about what it means with respect to being resilient with respect to these models and responsible AI. So let's start with what is responsible AI. Responsible AI is made up of 4 components. One is building models that are robust, meaning that they can handle changes in data environments, and we understand the behavior of those models over time. Explainable AI, knowing why the model works, what is driving that performance, and that falls into ethical AI. Is what drives that model ethical to use? Does it discriminate against any one type of person or not? And finally, efficient AI, being able to monitor the model in production, ensure that it is performing appropriately, and it's still valid to use this model under a responsible AI framework. If all 4 of these pieces are met, then we have the framework of what is responsible AI, where we can demonstrate that the models that we use are used properly, ethically, and will not harm. So let's start by looking at robust AI. So robust AI is focused on building models appropriately. When I say appropriately, it means that we take the time and the care to build them to withstand a variety of changes that they may see in production. We focus on a proper problem formulation, encompassing historical data, gathering a sufficient volume and quality of tags to build this model, and then having a solid and well-defined performance definition for these models. This takes time and effort to gather the data, to clean the data, and to define what the problem is we're trying to solve. From there, we go on to choosing the correct machine learning architecture. Some models are easier to understand, some models are more stable to changes, and this has to be factored into a decision around how to build the model for responsible AI. We choose the correct model, and then there's a bunch of testing that has to occur. We want to ensure that the models are not biased and do testing around ethics, and then focus on model scenario and stability testing, essentially focusing on whether or not the model will respond appropriately, let's say, during a pandemic or during a big financial upturn or downturn in the economy, and whether that has an impact on the performance of the model. These are really important when we're building the model at the very first time, because when we build this model in the lab, it needs to work in production, and production will always look and feel different to the model. And so these models have to be built robustly and be tested sufficiently to ensure that they can deal with changing environments. Now, here's an example of a robust AI model. A Falcon fraud model. These are models that we build to detect credit card fraud. And what I'm showing here is a model that experienced the prior to COVID and post-COVID situation that we're in currently. So the dark blue is today, and the light blue is prior to the start of the pandemic. And what we find is the same model experiences a change, and that change is that there are more high-scoring transactions. And that could be expected, right? Many of us have seen our own lives changed very dramatically because of the pandemic, both our ability to transact the way we want to transact and shifts in our spending patterns. But also fraudsters have upped their game and taken advantage of this pandemic to attack customers. And so what does it mean to be robust? Well, if you look at this plot, what it means is if I just work at a different score threshold, go from a 750 to an 800 score, and I review the same number of cases, the transactions, like 0.05%, what I find is the model continues to perform well. In fact, it performs very well. It goes from 26% roughly performance to 44% performance. Because when we understand that we built the model to perform in a changing environment, then it will continue to work well with small adjustments in how we interpret the score or operationalize that score. Now, why does this work? Well, we don't change overnight. We are in our human behaviors, they don't change that rapidly. And so when we build these robust models, what we're really focused on are the core latent features, the relationships that the machine learning model discovered, and how do they change or don't change, right? These human beings haven't changed the way they transact, but they may not travel anymore, or they may travel much less. But other parts of their behavior is exactly the same. So latent features impact both prediction of the model, bias, and stability. So the game is to focus on understanding very deeply what is driving this machine learning model, the latent features. Which brings me to the second leg, which is explainable AI. Explainable AI is looking inside of the model and being able to understand, much like this frog, what is inside and how does the frog function. And this is a difficult problem today because very often people will apply an algorithm called an explainable AI algorithm on top of the machine learning algorithm. And that's typically not sufficient. So more and more we're focusing on choosing the right architecture that is more transparent. And if the plot on the right-hand side shows that we have black box models on the left-hand side and white box models on the right-hand side, and the choice of the model can impact either the predictiveness or the explainability of those models. And so we have to make a critical decision. What's more important, explainability or prediction? In general, it's going to be explainability because we need to, from a responsible AI perspective, be able to explain why the model made the decision it did, either to a customer or to ourselves to ensure that we're making the right decisions. So how do you make a machine learning architecture explainable? Here's an example of a neural network, a very straightforward machine learning model. We have 6 inputs on the left-hand side, things like number of collection events greater than $500, total mortgage balance, a total number of trade lines. In the middle, we have something called the hidden layer. The hidden layer has 3 latent features, latent feature number 1, 2, and 3. These are the latent features that I mentioned prior. They are the things that drive the model performance. And what we do in machine learning is we optimize a cost function where we make a prediction based on historical data. How well does the model predict the outcome compared to the answers that I have in my historical data? And we change all those little green dots through a training algorithm until we start to make very small errors in prediction. In other words, that cost function on the upper right-hand part of the slide gets towards 0. When it does that, the machine learning model starts to make really great predictions. But unfortunately, it's hard to explain this model because latent feature number 1 is a function of 6 variables. And in large models, it might be functions of hundreds of variables. So it's nearly impossible to extract the meaning from the architecture itself. But if explainability is important, and it is for responsible AI, you can change the way that you'd solve this problem. You essentially say, I am going to optimize 2 things, both the error, the original CW, and add a new term, which is a summation of weights. And if I do that and I optimize and minimize that error, then I get a very different looking neural network-based model. This is a neural network-based model that now is constrained to have either 1 or 2 connections per each latent feature. And this is important because now it's a little easier to explain this model. In fact, it is a lot easier. And so if we look at latent feature number 2, this is a function of uh, variable 1 and variable 5. So it's a function of the number of collection events greater than $500 and the total mortgage balance. And the larger my mortgage balance, the bigger this gets, the higher risk I become. And the more collection events, how many times I was delinquent, also drives a worse risk rating. And so we can go look at and uncover and expose what the machine learning model learned. And that allows us to make sure that the features are stable, they're reasonable, and they should be used in a production environment. And they're not simply learning noise in a data set and won't generalize well when we put it in production. But it's more important than that. I need to be able to understand the latent features to answer the question whether or not a model is ethical. And that's a very big part of ensuring that we have a responsible AI framework and ensuring that the model is resilient. So let's take a look at this feature again, right? We said latent feature number 2 was a function of 2 variables. The first was number of collection events greater than 500. The second was total mortgage balance. And you can see in the colored box there, I have blue and red. And so the larger number of collection events I have and the larger amount of mortgage balances I have, I go to the upper right-hand corner of that box in the very red or high risk. If I have a small number of collection events and a small mortgage balance, I tend to be in the very bottom left, which is low risk. Perfectly makes a lot of sense to anybody, I would imagine. So what's wrong with this? Well, the variable itself looks good and it's reasonable. But to be ethical, we actually have to ask the question, how does it impact different groups of individuals? And so in looking at this, we need to look at classes of different customers. So the first class here would be the black stick people. The black stick people have a distribution of where they are in this matrix of total mortgage balances and collections greater than 500. Most of them are in very low collection events and all kinds of different mortgage balances. So they're in the bottom of that grid. And I've highlighted it there with this black hash. Likewise, from risk perspective, the majority of the black stick people are low risk. Now I go to my next subpopulation and I look at the orange stick people. And the orange stick people are different. They tend to be mostly low mortgage balances. Maybe they make lower incomes in general. And they have more collection events. Maybe they don't understand credit lending as well, and they have more delinquencies. They tend to be in the upper left. And if you look at that plot of blue and red, you'll see that the black stick people generally are all in the low risk, and the orange stick people tend to be congregated in the high risk. So although this variable looks to be fine and it makes sense, if we would use it in production, we would routinely give higher risks to the entire orange population and lower risks to the black stick person population. And that can be an ethical issue because one class is getting a different treatment than another class systematically. The best way to test for that is to expose these latent features and do these sort of analysis to understand whether we're comfortable or not with how different groups are represented in the behaviors of the latent features, because the latent features are driving that the model outcome. And over time, we may see that the data shifts and we'll have to reevaluate, which is important because the other major part of being ethical from an ethical AI perspective is to recognize that this is a continuous journey that we're taking. It doesn't stop when we finish building the model. In fact, it applies when we build the new model. It applies throughout the model's life cycle. And we must constantly re-examine the data and the model, whether we believe it to be ethical over time. In fact, here in the United States, the FTC has guidance. It says, make sure that your AI models are validated and revalidated to ensure that they work as intended and do not illegally discriminate, which means that we have a responsibility as scientists and users of machine learning models and AI to not say that's good enough when we built the model, but to continuously evaluate the model for bias and whether it is ethical or not. There's no better example of this as we are currently going through in the pandemic. The pandemic is impacting different people of socioeconomic statuses differently. And so all models need to be evaluated and reevaluated for ethical concerns, but you need to do that by looking at the latent features. And that's why it's so important that we identify through explainable AI what those latent features are, and we are able to do those tests over time as the data changes. Which brings me to the fourth and final leg of this stool, which is efficient AI, or the ability to monitor the models and to be able to maintain these models. And I love this picture. This is the back of a Jeep, which must break down very often because you bring all the tools with you for this drive. But we should think about models the same way, and machine learning is that they have to constantly be monitored for ethical usage. They will need to be tuned up and fixed along the way. And if we have that as a framework, it's a very healthy way to ensure that we are being responsible with our AI and usage. Part of this is that we must have a corporate guidance around how we build models. We cannot leave it to a data scientist's artistry, where Sam and Julie and Ernie all build models the way they want to build models. To be responsible means we have a blueprint for how models are built within a company or corporation. And all scientists follow that so that they can ensure that they've built it to a company standard where all the responsible AI attributes are being captured and monitored and measured. For me in my business, right, we start this with what's called an analytic tracking document. Our journey starts with a very detailed requirements document where we identify the project, the owner of this project, the project managers, scientists, timeframes. We get into the overview, the value propositions, the assumptions. And this goes on for pages and pages and pages that talk about the data, it talks about the assumptions, it talks about success criteria. It establishes the company's corporate standards around ethics, and it prescribes how that will be tested. So all scientists have to follow this, and this becomes a contract between myself and my scientists that we follow this corporate standard of responsible AI. If we don't have a standard like this to work in within our corporations, then we cannot be certain that everyone is building models ethically and responsibly, and that is a problem. To do so basically means that we have in those sort of documents and in these methodologies lists of requirements, data, sprints of what's going to be done when in the model build, explainability requirements, resources, bias detection, assumptions, approvals and changes to the model build as time goes by, success criteria, and robustness tests. So there's a lot of detail here to be monitored, but we need to take this very seriously because, again, if we're not building models from a responsible AI perspective, they will not be resilient. They will not stand up over time as the data changes. And worse yet, we may be discriminated against human beings with our automated machine learning. And we need to ensure that we're monitoring that that doesn't happen. To do that, one of the things that we do is we focus on the fact that it has to be auditable, right? A process is the best if we can go back and ensure that was followed. And so the blockchain gets used to put all these pieces of requirements and the achievement of those requirements into the blockchain. And if we do that, we have an auditable model development process. The way this works is in this blockchain, we're literally putting in pieces of the model development process. So here we have Jalan, who's extracted latent feature 31, Shafi, who's looked at that relationship from a compliance perspective, and me, who's approved it. That's all persisted. Likewise, sensitivity to geographic location, analysis, compliance, and approval. And also, very importantly, mistakes that are made get persisted to the blockchain. This is where we're trying to record the real life story of this model. So we have sensitivity to race, compliance testing was done, I've rejected it. They removed the variable, they completed the analysis, and they've done the compliance testing, and it's approved. We need the entire history of this because as we put these models in production, they will break, and we need to maintain them, and we need to know what to monitor. And if we do so, then what we essentially have are an ability to ensure that we are being responsible, where these model development blockchains are the user's manual for how to maintain these models and monitor these models to ensure that we are adhering to a responsible AI framework. With that, I want to thank you. It's been a pleasure to share this with you around the tenets of responsible AI. Thank you very much.